Good morning all.
The meeting playing record.
I request all of you to mute yourself. Madhav. 'Good morning everyone.
Good morning, sir.
Yeah, good morning. So is my voice is clear, Amma?
Yes, sir.
Guys, is my voice clear?
Yes, sir.
Is my voice clear?
Yes, sir.
I request all, please mute yourself. One second. Okay. Right. Yeah. So in the previous class, we are discussing about column n conditions, isn't it? Right. So let us discuss today with the Euler's theory. Okay. So Euler's theory will gives you the crippling or buckling load. Okay. In which where your column is subjected to fail. Okay. In terms of buckling. I mean, so at what load your column will fail? Okay, at what load your column will buckle or cripple? Okay, so that is going to be defined based on the Euler's theory. Okay, so let us discuss that today. So very important in this particular module, which is Euler's theory. Not only here, in all competitive exams like GATE, AE, AW, and all, this Euler's equation is very important. It will defines you to calculate the crippling load or buckling load of the particular column. Okay, then even we can able to differentiate with the kind of load. Okay, so which is the Euler's formula. Understand? Right? So let us discuss that today. Let me share you whiteboard. Okay. Yeah. So guys, what are the end conditions we discussed in the previous class?
Both ends are fixed.
Column end conditions, isn't it? So what are the end conditions? The first one, when the column is fixed at both ends, right? So what will be the effective length of the column?
0.5 actually.
Yeah. So let's see that. When the column is pinned, cantilever, yeah. So these are the 4 different end conditions where column is subjected to load. Okay. So basically the column is bent like this. For this, it will be like this. Okay. So these are all original length of the column, and this will be your effective length of the column. Isn't it? So what do you mean effective length? The distance between
2 point of lectures.
the distance between 2 point of contraflexures called effective length, isn't it? Yeah. So why I am discussing this again, you have to know. So why? Because the representation of the effective lengths will be in different ways. What is the effective length of this column? For the first one, effective length will be
0.5 times of
0.5 times of L. Okay. Yeah. So this can also be represented as L by 2. Avuna? So because not few students will by heart this. Kada? So instead of by hearting, okay, you have to know what do you mean effective length, how it can be represented. Okay. So that all you have to know. So that is the reason why I am representing in another way. So which is defined as distance between the two point of contraflexion. Can anyone tell me what is the other name for point of contraflexion? Everyone cheptara? What is the other name for point of contraflexion?
point of zero bending.
Point of
Zero bending.
no, point of inflection. గుర్తుపెట్టుకోండి, very 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 important. ఎక్కడ ఉంటే మీరు రాసుకోండి, very very important. The point of contraflexure can also be represented as point of inflection under. Okay na? There is this is the other name of that. Okay. Yeah. So what about this? The effective length of one end is fixed, other end is pinned.
0.7 times of L.
This can be represented as L by root 2. Isn't it? Yeah. So it can also be represented as like this anamata. 0.7 times of L and raichu, lekapothe L by root 2 and kuda raichu. Okay. Why? Because in your competitive exams, you may not find this option. You may find only options like this. So that's why you have to represent it even in this way. Okay. So here, what is that? Distance between top of the column and inflection point. Isn't it? Top of column and inflection point. Right? So this is nothing but an effective length of the column which is subjected to, which is fixed at one end and pinned at other. What is this? Third one? Cantilever. So what is the effective length of the cantilever?
2 times of L.
2 times of L. Okay. So obviously you can represent this directly like this, 2 times of L, even in this way. So what is this? So this is nothing but the free end. What happens, will always stay side by side, and the curvature in the length will be very similar to the upper half of the similar or simple column. Why? Because if you see in all other 3 columns, okay, the other end is somewhere supported. Avuna? This column is supported at fixed and other end. This column is supported by pinned at other end. This column is supported by pinned at other end. But what happens? This cantilever is very free to. It is very free to sway. అర్థమవుతుందా? స్వే అవ్వడానికి ఛాన్సెస్ ఎక్కువ ఉంటాయి అన్నమాట. దీన్ని స్వే అంటారు. So that's the reason why the free end will always sway sidewise, and the curvature of the length will be very similar to the upper half of the simple column. So that's why you have to take the other half of the column where it will be the 2L times will be your effective length output. Okay, so that's why it can be written as the free end of column will sway sidewise. Okay, that's why the curvature in the length, okay, curvature eppudu vastundi. So this is only half of the curvature. The other half of the curvature will be similar on the upper half of the simple column, right? So by that, the curvature in the length will be considered on other half of the column. Okay, so that's the reason why. So your length, effective length is 2 times of the L output. Understand? Yeah. And the last one, effective length will be
L, sir.
L. Okay, what is that? Simple. So effective length will be your actual length output. Why? Because there is no point of counterflexures taking place here. Why? Because the bend moment is 0 at the support where they are hinged or pinned. That's why your effective length will be going to take it as the actual length of the member. Understand? So very, very important number. So you have to even remember all these values in this mode. Okay. So to better understanding of the end conditions. Okay. Right. So let's discuss about the Eulers theory now. Very important, Eulers theory. Okay, yeah. So before deriving or before studying about any equation, there will be few assumptions, isn't it? So there will be definitely few assumptions. As like here also we are having few assumptions. So let's discuss these assumptions first, because even in your external examination, these assumptions are very, very important. Okay, so let's write the assumptions one by one. First assumption, the column is initially straight and of uniform lateral dimension. And column is initially straight. And so there is no deviation in the length of the column. So the column is initially straight and of uniform lateral dimension. And lateral dimension of the column is always uniform. Column lateral dimension is uniform. What do you mean this? Prati oka assumption we have to represent or to understand in very diagram related ga manam ardham chesukovali. Okay, so what this assumption is saying, if you take any column, the column should have should be straight first of all, and the cross section, kada, this cross section should be same at every point. Ikkada cross section ela undo, ikkada kuda alage undali, ikkada kuda alage undali. Okay, so this is right. Which is wrong? Edi mana assumption lo wrong ante, మీరు చెప్పండి, is the cross section is same at every point?
No, sir.
No. So that's why, so this is right and this is wrong. Okay, so we have to consider our column as right, and the lateral dimension ante meaning ఏంటంటే ఇదన్నమాట. Okay, so this B D L. Okay, L is equal to longitudinal dimension. ఎందుకంటే చాలా మందికి తెలియదు what do you mean lateral dimension అంటే. B and D are lateral dimensions under. Understand? Clear? So this is the first assumption. Okay, I hope you all understand. Even so, why? Because even if you can't able to remember the statement, by just remembering the diagram, even you can able to write the statement. Okay, that's why I'm representing it dramatically. Okay, next one. Next assumption. Second assumption. Indeed, the compressive load is exactly axial and it passes through the centroid of the column section. Very, very important. Emanta compression load is axial. Okay. Theoretical right. Okay, don't mind because I am not dictating you. Okay, so you have to understand the concepts. Compression load is always axial and it passes through the centroid of the column section. Under. What do you mean this? So let me take a column. Okay, so this is the cross section of the column. So whatever the load acts on the column, this column should always act axially and the load should always pass through the centroid of the section. The axial load under. Okay, so that means it always passes through the centroid of the section. So this is your centroid and this is called axial load, where the load is passing axially. Understand? This is my assumption. Wrong enti. So which we should not consider means see sometimes you may not expect so column where it will be subjected to load like this. Okay, so this is your axis, centroidal axis, but the load is with some
Eccentricity.
column.
Eccentricity.
Eccentrical distance. Okay, so by that what happens if you take your section, so this is your centroid and the load is acting here. Okay, so there will be an eccentrical distance, so these are not supposed to be considered. Okay, so that's why it is telling, so you have to make this assumption right and this is wrong. Okay, compression load axial ga undali. Okay, compression andi. Okay, compression load axial ga undali and it should pass through the centroid of the cross section. Clear? Right. Third assumption. What is the third assumption? The midend of the column is perfectly homogeneous and isotropic. This equation is common. Material is homogeneous and isotropic. Okay, right? What do you mean homogeneous? Mana chala sari discuss chesam, but again, just for better understanding. What do you mean homogeneous? Same mechanical properties throughout the section. Very, very important. Okay, na gurtu pettukondi. Homogeneous ante entamma? Same mechanical properties throughout the section. What do you mean that same mechanical properties ante? Let us take a column. Okay. If I see the compression strength of the column, which is subjected to load here. Okay, compression strength and stress ankondi. Okay, so can anyone tell me what is the stress formula? Compression stress formula? Compression load by
area.
cross-sectional area of the column. Understand? Right. So what is the compression strength at this point? Sigma C is equal to PC by A. మరి ఇక్కడ సేమ్ ఉంటుందా వేరీ ఉంటుందా?
సేమ్ సార్.
సేమ్. ఇక్కడ
సేమ్.
సేమ్ ఉంటుంది. అంటే ఎక్కడ throughout its cross section ఎక్కడ తీసుకున్నా throughout the length ఎక్కడ తీసుకున్నా compression strength ఎందుకంటే compression strength is one of the mechanical property. Okay, so by that it will have the same mechanical property throughout its length or throughout the cross section. Those materials comes under homogeneous material. Not only compression strength, okay, tensile strength avachchu, shear strength avachchu, bending strength avachchu, okay, hardness avachchu, right? So like this, torsional strength avachchu, they are all mechanical properties. Understand? So this is the meaning of homogeneous. Then what do you mean isotropic?
Elasticity.
Identical elasticity.
Very good. Same, identical, elastic constants. Ante, so let us take member column. మనం కాలమ్ గురించి మాట్లాడుతున్నాం కాబట్టి కాలమ్ గురించే డిస్కస్ చేద్దాం. ఓకే, రైట్. సో ఇది కాంక్రీట్ కాలమ్ అనుకోండి, ఇది స్టీల్ కాలమ్ అనుకోండి. ఓకే, సో ఇది కాంక్రీట్ అంటే ఆర్సిసి. ఓకే, ఇది స్టీల్ కాలమ్, రైట్? So what do you mean identical elastic constants? And what are the elastic constants? First we have to differentiate. What are the elastic constants, Amma? Elastic constant.
Poisson's ratio.
G or C is an elastic constant. Mu is an elastic constant. Avuna? Right. So coming to E. So if this is concrete material, it is steel material. Ante universally materials will have same elastic constant anamata. So steel yokka E value enta 2 into 10 power 5. Yokka G or C value enta evarkana gurtunda?
1 into 10 to the power 4.
Entama?
1 into 10 to the power 4.
1 into 10 power 4. What is the bulk modulus? Okay, we have to calculate. Okay, but it will be common. Why? How you are going to calculate bulk modulus? Volumetric. How you are going to calculate? Volumetric stress by volumetric strain. Ilaga meer bulk modulus calculate cheస్తారు. Mu. What is mu for steel amma? Gurtunda evarkana?
0.3 to
0.3 to 0.4 మధ్యలో ఎక్కడో రేంజ్ లో ఉంటుంది. ఓకే, సో లైక్ దిస్, these are all elastic constants of steel. ఇలాగే కాంక్రీట్ ఆర్ ఆర్సిసి కి కాన్స్టెంట్ వాల్యూస్ ఉంటాయి అన్నమాట. దిస్ వాల్యూ won't be similar with another material, కంపల్సరీ ఉండదు. ఓకే, in that way if any material is having the same identical elastic constants, ఈ వర్డింగ్ చాలా ఇంపార్టెంట్ ఉందనుకోండి, so those materials comes under isotropic materials. Okay, ఇదే డిఫరెన్స్. ఇక్కడ సేమ్ మెకానికల్ ప్రాపర్టీస్, ఇక్కడ ఐడెంటికల్ ఎలాస్టిక్ కాన్స్టెంట్స్. Okay, this is the third assumption where we have to consider. Okay, fourth one. What is the fourth assumption? Pin joints are frictionless and fixed ends are perfectly rigid. Very important assumption. ఏమన్నారు? Pin joints are frictionless. Guys, if you are coming like this in between, what is use cheppandi? Next, fixed ends are perfectly rigid. Ante entamma? What do you mean this assumption? Let us take pin joint. Pin support ఎలా ఉంటుందమ్మా? ఇదేనా pin support? Right? What are the forces acts in the pin support? There will be a vertical force and there will be horizontal force. Ante it is free to rotate. Free to rotate. So by that it is frictionless. Okay, అదే మీకు friction ఉందనుకోండి అప్పుడు ఏమవుతుంది it is not going to be rotated freely. Okay, so that's why pin joints are frictionless where it is free to rotate. Okay, so where it is not free to move, it won't move in horizontal direction, it won't move in vertical direction. Okay, so that's how we are supposed to be assume pin joints are frictionless. Amaridi, this support, there will be horizontal resistance, there will be vertical resistance, there will be moment. అందువల్ల ఫిక్స్డ్ సపోర్ట్ ఈస్ పర్ఫెక్ట్లీ రిజిడ్. నో మూమెంట్ కాదు, మూమెంట్ ఇన్ ఎనీ డైరెక్షన్. ఏ డైరెక్షన్ లో మూమెంట్ ఉండదు అనమాట. ఓకే, సో దట్ ఈస్ వాట్ ఫోర్త్ అజంప్షన్ in column in Eulers theory. Okay, right. Next assumption, fifth one. What is that? The weight of the column itself is neglected. Very important. Weight of the column is neglected. Enduku? Why we have to neglect the weight of the column? Let us see. See, it's an assumption, amma. Okay, but practically you may ask, sir, practical weight of the column untundi kada, so which is a self weight. So, but why we are not considering ani meer adagachu. Okay, so in design we are going to consider self weight of the column. No worries. But for developing an equation, we have to neglect. Then only we can able to derive the equation. Understand? Ante enti? So, ipudu idi column. Okay. ఇది ఒక స్టీల్ కాలమ్ అనుకోండి, స్టీల్ కాలమ్. ఓకే, సో విచ్ ఈస్ సబ్జెక్టెడ్ టు లోడ్ P ఆఫ్ 500 కిలోన్యూటన్. మరి రెసిస్టెన్స్ ఎంత ఉంటుంది? సేమ్ కదా, కంప్రెషన్ ఫోర్స్ కదా కాలమ్ లో ఉండేది, రైట్? ఇది ఇప్పుడు ఫర్ మై డిజైన్, ఐ మీన్ ఫర్ మై అనాలిసిస్, వాట్ ఐ హ్యావ్ టు డూ? ఐ నీడ్ టు కన్సిడర్ ఓన్లీ లోడ్ P. లోడ్ P మాత్రమే తీసుకోవాలంట. Okay, so which is right? I should not consider self weight of column తీసుకోకూడదు. Self weight అంటే W అనుకోండి, it should not be taken. ఇది చెప్తున్న assumption. Okay, can anyone calculate what will be the self weight of the column? ఈ కాలమ్ యొక్క self weight ఎంత ఉంటుందో చెప్పగలుగుతారా? If I give the dimensions, let us take, let me give the dimensions. By that you should know how to calculate the self weight. Length 1 meter అనుకోండి. Okay, width 100 mm అనుకోండి, depth 100 mm అనుకోండి. Okay, material steel. ఎవరైనా చెప్పగలుగుతారమ్మా సెల్ఫ్ వెయిట్ ఎంతో? హౌ టు క్యాలిక్యులేట్ సెల్ఫ్ వెయిట్? L into volume, E into D into self weight. Self weight and density kada, right? Guys, so please don't write anything. 1000 into 1000 and write. Why? Because let me write in meters directly. 1 into 0.1 into 0.1 into what is density of steel, amma? What is density of steel?
Concrete, yes, sir.
Steel. నేను స్టీల్ యొక్క డెన్సిటీ అడుగుతున్నాను. స్టీల్ డెన్సిటీ ఎంత?
7840 kg per meter.
7.85 kilonewton per meter cube.
7850 kg per meter cube. గుర్తుండాలమ్మా, they are all standard values. Multiply this with 7850 kg. ఎంత వస్తుంది వాల్యూ ఇది? What is the total value here in terms of kg? ఎంత క్యాలిక్యులేట్ చేయండి. 1 into 0.1 into 0.1 into 7850.
78.5 kg, sir.
78.5, sir.
78.5 kg అంటే ఎన్ని న్యూటన్ అమ్మా? How to convert kg into Newton?
0.0785 kilonewton.
How to convert kg into Newton?
into 9.81, sir.
Very good. ఎంత 770
770, sir. 85.
ఓకే, ఇట్స్ ఓకే. అంటే 770 న్యూటన్ లోడ్ ని మీరు కన్సిడర్ చేయకండి అని చెప్తుంది. ఓకే, యూ హ్యావ్ టు కన్సిడర్ ఓన్లీ లోడ్ P ఫర్ డిరైవింగ్ ద డెరివేషన్ ఆఫ్ యూలర్స్ ఈక్వేషన్. ఓకే, మీకు అర్థం అవడం కోసం చెప్పాను అంతే. మీరు అనుకోవచ్చు సార్ 770 న్యూటన్ కూడా చాలా ఎక్కువ వెయిట్ కదా సార్, అంటే 78 kg 78 kg కూడా ఎక్కువ లోడే కదా, వై షుడ్ నాట్ కన్సిడర్ అని మీరు అడగచ్చు. సి, in your point of view, you may think 78 kg is more, but in designing the column, 78 kg is negligible. చాలా తక్కువ వాల్యూ అన్నమాట అది. సో అలాంటి చిన్న చిన్న వాల్యూస్ ని మనం కన్సిడర్ చేయాల్సిన అవసరం లేదు. when you okay, sorry, where is our screen? Sorry guys, in between there is a small internet disconnection, so that's why it's come out. Okay, okay, so as we are discussing the fifth what is that assumption, so what it is saying, Amma, so we should avoid the self weight of the column. Okay, why? Because it will be very less. Andike meek example calculate chesi chupichanu. Okay, so if you take 1 meter of the column, the self weight of the column will be around 78 kg. Okay, so which is very negligible when you are considering the whole column as a big one. Understand? Okay, and next assumption, sixth one. So there are two assumptions, a few more. Okay, sixth one. Kanpistunda clear? Guys, it is visible?
Yes, sir.
Yes, sir.
Sixth assumption, the column fails by buckling alone. The column fails by buckling alone anta. Chudandi enta important statement o idi. What do you mean this? Let us take column. Em column amma idi? Long column or short column?
Long column, sir.
Why we should consider long columns? Why we should not consider short column?
Buckling occurs in long column, sir.
Very good.
Crushing occurs in short column.
Exactly. So long columns will buckle kabatti. Buckling load should be calculated based on the Eulers theory. Ante Eulers theory is only relating with the long columns which will undergo buckling. Okay, ఇక్కడ నేను చెప్తున్న assumption ఏంటి? The columns fails by buckling alone. అంటే what do you mean this? So when the load is passing axially, మన assumption, first assumption ఏంటి? The foremost assumption ఏంటమ్మా మంది? The load should always pass through the centroid of the section. If the load is passing through the centroid of the section, column will fail under any other way?
No, sir.
So column never fail when load passes through its axis. Okay, right? Mari ela fail అయ్యే ఛాన్స్ ఉంటుంది? If the load is more load, ela fail అయ్యే ఛాన్స్ ఉంటుంది? So the column may buckle like this if the load is more. And there is a possibility of buckling in the column in any lateral dimension. Atu gaani itu gaani buckle అయ్యే chances ఎక్కువగా ఉంటాయి అన్నమాట. Okay, buckling may happen when axial load is more. Okay, so ఎంత లోడ్ కి అది బక్లే ఛాన్స్ ఉందో మనం క్యాలిక్యులేట్ చేయడానికే we are deriving the Eulers theory. అర్థమవుతుందా? So this is what the main purpose of Euler's theory. Only to calculate the buckling load at what load your column may buckle. అందువల్ల we are going to consider the column fails by buckling alone. Understand? Okay. So this is what about the buckling consideration for an Euler's theory, right? So this is the other assumption. And the last assumption, seventh assumption. Limit of proportionality is not exceeded. Limit of proportionality is not exceeded. What do you mean this? What do you mean this? What happens when the limit of proportionality is not exceeded?
Stress is directly proportional.
Very good, very good. Your stress is directly proportional to strain. Okay, ante enti?
It obeys
Your
Hooke's law.
load, this is your deformation. Till this point is called limit of proportionality. Okay, so at this point, so that means your stress is directly proportional to strain, which indicates linear curve. Okay, so అందువల్ల లిమిట్ ఆఫ్ ప్రొపోర్షనాలిటీ ఎక్సీడ్ అవ్వదు, ఇక్కడ వరకే ఉంటుంది మీ కాలం యొక్క వాట్ ఇస్ దట్ స్ట్రెస్ అండర్ డిఫార్మేషన్. ఓకే, ఇది దాటితే ఏమవుతుంది? యువర్ గ్రాఫ్ విల్ చేంజ్. వెన్ యువర్ గ్రాఫ్ విల్ చేంజ్, automatically your derivation of the Euler's theory will also change. Why? Because till this extent only your Euler's theory or equation is applicable. Okay?
Sir,
Yeah, chapter.
sir, we are having class, sir.
Yeah. Finish. Yeah, 1 minute. Okay, Euler's theory or equation is applicable only up to the limit of proportionality. Okay, beyond this point, your Euler's theory is not applicable. Can anyone tell why Euler's theory is not applicable beyond this point? Why? Because your stress is not directly proportional to strain beyond the limit of proportionality. Okay, at the same way, your graph is not linear. Kada? మీ గ్రాఫ్ ఎలా ఉంటుంది చెప్పండి? ఇక్కడ లీనియర్ వచ్చిన తర్వాత ఇట్ విల్ మే లైక్ దిస్ ఆర్ ఇట్ విల్ గో లైక్ దిస్, ఇట్లా ఉండొచ్చు. సో ఇఫ్ యు సీ ద గ్రాఫ్ ఎట్ దీస్ పాయింట్స్, యువర్ గ్రాఫ్ ఈస్ నాన్ లీనియర్. వెన్ యువర్ గ్రాఫ్ ఈస్ నాన్ లీనియర్, సో యూ కాంట్ derive any derivation. Why? Because at every point the load versus deflection is varying. ప్రతి పాయింట్ లో లోడ్ స్ట్రెస్, స్ట్రెస్ స్ట్రెయిన్ ఆర్ లోడ్ డిఫార్మేషన్ విల్ వేరీ ఎట్ ఎవ్రీ పాయింట్. సో దట్స్ వై వీ షుడ్ నాట్ కన్సిడర్, okay, while deriving any derivation beyond the limit of proportional point. Okay, so that is the meaning of this assumption. Understand? Clear? So with this note, we are going to derive Euler's formula or Euler's equation in the next class. So once we write the formula, then we can solve the problems on Euler's theory. Okay, that's it. So that's how we can able to finish the 4th module very easily. Okay, so tomorrow we will discuss the Euler's equation. Okay guys, right, see you. Bye. You can continue to the next class.